Hello everyone. Let us learn the relation between molar mass of solute and relative lowering of vapor pressure in this particular module of the chapter Solution and Colligative Property. We already know that delta P upon P01 is equals to X2, that is nothing but the relative lowering of vapor pressure is equals to the mole fraction of solute, and I can say that here delta P is nothing but P01 minus PS. So my equation becomes P01 minus PS upon P01 is equals to X2, and in place of X2 we are going to write N2 upon it is N1 plus N2, where the formula for N1 is W1 upon MW1 and the formula for N2 is W2 upon MW2. Let us substitute these values of N2 and N1 over here. So we get P01 minus PS upon P01 is equals to W2 upon MW2 divided by, it will be W1 upon MW1 plus it will be W2 upon MW2. But since we are learning colligative property, the limitation is that it is only applicable for dilute solutions where the moles of solvent is much greater as compared to that of the solute. So whenever you have a comparison of moles of solvent and solute, you have to neglect the moles of solute. So N2 is neglected over here. So when I say N2 is neglected, you have to neglect from that particular equation, and hence I get P01 minus PS upon P01 is equals to N2 divided by N1. Further, N2 can be written as W2 upon MW2 divided by W1 upon MW1. On rearranging, I get W2 MW1 upon W1 MW2. And that's the final formula which you're supposed to use when you have a numerical based on relative lowering of VP. Let's take a numerical. It says that the vapor pressure of solution containing 13 into 10 to the power minus 3 kg of solute in 0.1 kg of water at 298 Kelvin is 27.371 millimeters of mercury. Calculate the molar mass of solute given that the vapor pressure of water at 298 Kelvin is 28.065 millimeters of Hg. Perfect. Let us first write given. In that we'll write solvent. The solvent is water. Its molar mass is 18 gram more inverse. And if we talk about the solute, they have not specified in the question, so solute is unknown. The first data is weight of solute W2, which is 13 into 10 to the power minus 3 kg, and the second data is the weight of water solvent W1, which is 0.1 kg. And the third data is the vapor pressure of the solution, that is PS, which is 27.371 millimeters of Hg. And the last data is the vapor pressure of water. Water is pure solvent, so P01 is 28.065 millimeters of Hg. What we need to find over here is the molar mass of the solute, that is MW2, and as told you, we are supposed to use a formula P01 minus P1 upon P01 minus PS upon P01 is equals to W2 MW1 upon W1 MW2. With this data, let's see the solution. We have this formula. Let us rearrange the formula in terms of MW2. So I get the formula as W2 MW1 P01 divided by W1 bracket P01 minus PS. W2 is 13 into 10 to the power minus 3 kg, and I want in grams, that is nothing but 13 grams. And MW1 is 18, P01 is 28.065. W1 is 0.1 kg, and I'm going to write it as 100 grams, and the bracket will be 28.065 minus 27.371. Let's see what do we get. In the numerator I get 6567.21, and the denominator I get 100 multiplied by 0.694, and the units in the numerator is gram mole inverse millimeters Hg. That's a possible unit which I get in the entire equation. Now let us continue from the same equation. On a further solving, I get the answer of molecular weight as 94.63 gram mole inverse. That's all we have for this particular module. Thank you so much.
इसे सॉल्यूशन बनता है.